All right, there are several basic functions that high school students are going to encounter. First one's linear, that's y equals x squared is quadratic, y equals x cubed is cubic, y equals the square root of x is the square root, y equals 2 to the x power or any other number to the x power is an exponential, y equals 1 over x is a rational. These are just all different functions. The two that are circled are the two that we are going to encounter in coordinate algebra. So although we're looking closely at just the two functions, transformations affect all the functions the exact same way. For example, if I wanted to move the function right 2 places, I'm going to subtract the number 2 from all the x's. So if I said I want to move all the functions right 2 places, I'd subtract 2 from the x in the linear. I subtract 2 in the x in the quadratic before I squared it. I would subtract 2 from the x in the cubic before I squared it. The 2 is with the x here under the square root. It's with the x here in the exponential. It's with the x in the denominator of the rational. Anything that happens with the x moves it left and right. So I have to put that minus 2, which is the opposite of what you would think, because it's always the opposite when it's with the x, in with the x. Now for continuing with that, if I said I want to move all the functions down 4, I have to subtract 4 from the whole thing. X minus 4. The whole thing's a linear function of x, I subtract 4. The whole quadratic, x squared, minus 4. X cubed, minus 4, moves it down. The square root of x, then minus 4. 2 to the x power, minus 4. 1 over x, then take that whole thing and subtract 4. That is going to move it up or down. So the left or right's inside and the up or down's outside, and it affects every function exactly the same. Again, reminder, we are just doing exponential and linear. So some things to remember about transformations. Things that happen to the x inside the function, usually inside parentheses, change how graphs move left to right. It changes the value of the x because it's happening to the x. If it's not happening directly to the x, then it's changing how the graph looks moving up or down. So it is changing the value of the y. All right, so we're only dealing with linear and exponential, so there's no need to try to memorize all of those previous functions. I just wanted to show you how transformations work the exact same way for all of them. So the things that you are going to need to be able to do, you're going to need to be able to look at a graph of a function and move it according to its transformations. You need to be able to look at a function and identify the transformations. And then you need to create a function given the type and a type of function and a list of its transformations. So the first one, given a graph, move it accordingly to its transformation. So it's telling you that f of x is graphed, and it wants you to graph the graph y equals negative 2 times f of x plus 1 plus 2. Good grief, that's a lot of stuff happening to that graph. So the very first thing I want you to do is circle all of the different transformations. So that's all that is not circled is f of x. Okay, that's the only thing that's not circled. All right, so then I'm going to pick 3 points from the graph and put it on an xy chart. I picked the point 0, 1, which is right here, 1, 2, and 2, 4. And I just put them on an xy chart. Okay? And then I want to create as many more xy charts as I have circles. So I'm going to look back up here and I have 1, 2, 3, 4 circles. This negative is separate from the 2 because the negative is what flips it up and down and the 2 stretches it, so it's two different things. Alright, so here's my first xy chart and here's one xy chart for every circle that I have. Step 4 says determine how each circle transformation affects the x or y, and I need to do that to use it to fill in the next chart. And then it says repeat step 4 to all charts are filled in. So I'm going to take one transformation at a time. Since this is not happening directly to the x, the negative will be applied to all the y's. So I'm going to rewrite the x's because I'm not changing them, and I'm going to make all my y's negative. Alright, that transformation's done. On to the next one. The next one says multiply by 2. Again, because it's not happening directly to the x, I'm only going to multiply my y values by 2. I'm going to rewrite my x's, and I'm going to multiply all these by 2. So negative 2, negative 4, negative 8. The next one says add 1. Now remember, this always is the opposite. So what I'm going to do is I'm going to subtract 1. Because it's happening directly to the x, I'm going to subtract 1 from the x values. So my y's are going to stay the same this time, and I'm going to subtract 1. So 0 minus 1 is negative 1, 0, 1. And my very last xy chart says I need to add 2. Again, it's happening outside this parentheses, so it's happening to the y. So I'm going to add 2 to all my y values. So I'm going to rewrite my x's. So -1, 0, and 1. And then I'm going to add 2. -2 plus 2 is 0. -4 plus 2 is -2. -8 plus 2 is -6. Once all my charts are filled in, I need to plot the points in my last chart. So I'm going to go over to -1, 0, and I'm going to plot a point. Then I'm going to go to 0, -2, and I'm going to plot a point. Then I'm going to go to 1, -6, 1, 2, 3, 4, 5, 6, and plot a point. Connect my dots. And this graph has been reflected over the y-axis, moved to the left 1, moved down 2 spaces, and stretched that increases twice as fast. So if you'll follow this every time, you'll get to the correct y chart. And sometimes you'll need 4, sometimes you'll need 2. All right, but those are the points you need to plot. When you connect those dots, you're done. All right, given a function, identify the transformations. So you got to keep in mind our two parent functions are going to be y equals x and y equals 2 to the x power. All right, so first thing you do is circle the transformations until everything except the parent function is circled, and then describe the transformation. So this one, the x is on the ground floor, so that's going to be my parent function. So I'm going to circle everything except x. Okay? Multiply by 2 means stretched by 2. A +1 inside the parentheses means I move it left 1. Remember, it always goes opposite of what you think. And a -3 on the end means I move down 3. The next one, this is going to be an exponential function because my x is upstairs. I've multiplied by 1/2 because it's a fraction. I know it shrink by 1/2. I know I'm going to move it to the left 3. And I'm going to move it down 1. All right, and last but not least, this is an exponential again. The negative out front means reflect. Oh, let's circle them. And then this one, and then that one, and then this one. I didn't circle it the last time. Got ahead of myself. So this one means reflect over x-axis. This one's inside with the x, so that's going to be reflect over the y-axis. This one says +1 with the x, so that's going to be left 1. And this is a +7 outside, so it's going to be up 7. All right. Last but not least, given a description, draw the function. So start with the parent function that has space for all kinds of transformations and fill in the blank. So an exponential with a base of 3. So y equals, we're going to leave some space in case there's something here. A base of 3 to the x power, we're going to leave some space in case there's something there, and some space in case there's something there. So it has been shifted up 2 spaces, so I know my +2 goes on this end. It has moved left 6 places, so I know that means I need to add 6 right here. And it is reflected over the x-axis, so this needs to be negative. So when it's all said and done, it's y equals -3 to the x plus 6 plus 2. All right, a linear function. All right, so I'm going to start with just y equals x with some space around it. That has been stretched by 2, so I'm going to multiply 2 outside. Moved up 1 space, there's going to be a +1 out here. And right 1 space, so I need to put parentheses around this and make it -1 inside. And I'm done. I don't even have to rewrite it.